Hi, this video will demonstrate how to write an equation for a line that passes through two given points. So my points in this case is -3, 2, and 3 and 4. And now I can use either form of the equation for the line, either the slope-intercept or the point-slope. And we'll go through both and show how they actually both give us the same example. But regardless of which equation I'm going to use, my first step is going to be to calculate the slope. The slope of the line can be defined as the change in y over the change in x. More exactly put, it's y2 minus y1 divided by x2 minus x1. Alright, and now x1, y1 is one of my points and x2, y2 is another. So up here I'm just going to assign my first point x1, y1 and my second point x2, y2. I can certainly flip-flop this. I can make this my x2, y2 and this my x1, y1, and I will end up with the same answer. All right. So from there, in order to get my slope, I'm going to simply just substitute. For y2, I'm going to put a 4 minus y1, which in this case is a 2, okay, divided by x2, which is 3, minus, all right, x1, which is minus 3. Now the key to the slope is keeping track of your signs. Okay, that's probably the number one error. So 4 minus 2 in the numerator gives me a 2. And 3 minus a minus 3 actually gives me a positive 6 because the negative and the negative cancel. So my slope in this case, if I reduce it down, is 1/3. Okay, so now I know my slope. So first, let's look at if you want to use the slope-intercept form. So I know y is going to equal 1/3 x. All I've done is plug in my slope here, for my slope here, plus b. Now I don't know what the y-intercept is, okay? But I do know what x and y is. Actually, I know two x and y's. I've got a point here and a point here. You can use either one of these to plug in for x and y and solve for b. Either one, it doesn't matter. At this point, you actually have too much information. You only need to use one of these points. All right. However, you can use the other point to check. So I'm going to actually use this point. All right. So my y would be 4, all right, equal to 1/3 times 3 plus b. Okay. And now I see here that my 3's cancel. I'm just left with 1. I get that 4 equals 1 plus b. If I subtract 1 both sides, I get that 3 equals b. All right, so now I can go back, and I'm not done with this problem. I have to rewrite this as an equation of a line. So y is going to be equal to 1/3 x plus b, but I know that b is 3. Now, just as I was talking about before, I should be able to plug in this other point that I didn't use and it be a true statement. -3 times 1/3 would give me a -1, plus 3 would give me 2, so that makes that true. All right. Alternatively, I could have used the second equation here. If I'd have used the second equation, I simply pick a point. Again, I have too much information. Just pick one of your points. It doesn't matter. And what you're going to do is plug in that point for x1, y1. So in this case, I get y equals my slope. The slope's the same no matter which form I use. I get x and now minus x1. So here I'll just use this point. But remember, it's minus x1, so it's minus a minus 3. And then plus y1, plus 2. Okay? So here I would get y equals 1/3 x plus 3 plus 2. Now notice that these two don't look exactly alike. But if I take this one step further and expand this by distributing this 1/3, okay, I would get that y equals 1/3 x, okay, because 1/3 times x gives me 1/3 x. And then 1/3 times 3 would leave me plus 1. And now I have my plus 2 out here. So I get y equals 1/3 x plus 3. So regardless of which equation or form of a line that I choose to work with, I will end up with the same answer. And now this is the equation written in slope-intercept form, and this would be my equation written in point-slope form. Both are equally correct.